Hello everyone. Today we are going to discuss the new topic, periodic classification. Periodic classification. So how the elements are classified? The elements are classified into four blocks, S, P, D, F, four blocks. Okay, and four types of elements also we can say. What are the four types of elements? The elements are what? Representative elements, noble gas elements, transition elements, and what? Inner transition elements. So now all the classification of elements into different blocks, okay, in the form of periodic table we are going to discuss today. Suppose you take a periodic table, modern periodic table, modern periodic table. So in this modern periodic table, okay, different blocks are there here, SPDF blocks are there. Suppose you take first group 1, IUPAC group number 1. That is what? Group number 1 is called Roman number 1A. What we say? Roman number 1A. What are the elements? Hydrogen. Okay. Next what? Lithium, sodium, potassium, rubidium, cesium, and francium. And what are the elements of second group? Beryllium. Next what? Magnesium, calcium, strontium, barium, radium. Their second group elements. Here, group 2. Group 2 means what? Roman number 2A. Okay, these are S block elements. Now, what are these here? S block elements. S block elements, right now. So now here S block elements are there, P block elements are there. S block elements and P block. In S block, how many groups are there? Two groups only. Group 1, group 2. IUPAC group number 1, IUPAC group number 2. These are what? Alkali metals, and these are what? Alkaline earth metals. Alkaline earth metals. So after this, now next what is there now? After calcium, what is there here? Scandium is there. Scandium. Okay. Titanium, vanadium, chromium, all these there here. Up to what now? Zinc. Up to zinc. Suppose you take up to zinc. Okay. Now scandium to zinc. These elements are called what now? 3D series elements. They are D block elements. In these D block elements now, the electron, last electron, that is differentiating electron, enters into what? 3D orbitals. Into 3D orbital, the last electron enters. The last electron of the element is called differentiating electron. The differentiating electron of these elements enters into what now? 3D orbitals. That's why these elements, scandium to zinc, are called 3D series elements. This 3D series is what now? First transition series. What is called? First transition series. It is first transition series we say. So after this now, here it is group 3. Scandium belongs to what? Group 3. And IUPAC group number what? IUPAC all notation what? Roman number 3B we say. Group 3, IUPAC group number 3. Otherwise, all notation is what? Roman number 3B we say here. So scandium is there here. Scandium. After this, yttrium. Okay. Next, lanthanum. Lanthanum. After that, actinium. AC. Actinium. So these four elements. What are these? Scandium, yttrium, lanthanum, actinium. These elements belong to what? These elements belong to what? Group 3. IUPAC group number 3. Is that clear, ma? So scandium, yttrium, lanthanum, actinium. Next, group 4 also you have to remember. Group 4. IUPAC group number 4 elements. So after scandium, what is there next? After scandium, titanium is there. Titanium or titanium we wish. So I'll write this one here. First write down Ti. Ti means titanium. Next, after the zirconium, Zr, zirconium. After that, hafnium, HF, hafnium. And next one is what? Rutherfordium. Rutherfordium. Okay, ma. So scandium, titanium, yttrium, zirconium, lanthanum, hafnium, actinium, Rutherfordium. Rutherfordium. So group 4 is called Roman number 4B. Roman number 4B. Otherwise, group 4 we say. Is that clear, ma? So group 3 elements, 4 elements you have to remember. Group 4 also 4 elements you have to remember. Okay. Next, the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, all these elements up to zinc. These all elements belong to which series I told? 3D series. 3D series is called what now? The transition series. The D block elements are called what? Transition elements. Transition elements. So the first transition series is what? 3D series. 3D series starts from what? Scandium. Ends with what? Zinc. So scandium to zinc, all these 10 elements. The scandium 21 to zinc 30. All these elements called what now? 10 elements called 3D series elements. 3D series elements. So 3D series contains how many elements? 10 elements. Remember. Next. So now here the Y means what? Yttrium here. YTTRAUM. YTTRAUM. Yttrium, zirconium. Up to, so in this group 12 it is. What is my group 12? Group 12 is also called Roman number 2B. What we say? Roman number 2B or group 12. Group 12 elements were zinc, okay, cadmium, mercury, copernicium. So copernicium Cn, Hg mercury, Cd cadmium, Zn zinc. So zinc, cadmium, mercury, and copernicium. These 4 elements belong to what? Group 12. What are they? Group 12 elements. Remember. So now here, yttrium, zirconium up to cadmium. These all elements are called what? 4D series. 4D series elements. So the second transition series is what? 4D. The first transition series is what? 3D. Second transition series 4D. The 4D series, that is second transition series, starts from yttrium, ends with cadmium. Next, lanthanum, hafnium, hafnium up to what? Up to mercury. These all elements are called 5D series elements. What are these called? 5D series elements. Okay, ma? Next, actinium, rutherfordium, and up to copernicium. These all elements are what? 6D series. 6D series. Now, totally how many transition series? The D block elements are called transition elements. Group 3, IUPAC group number 3 to IUPAC group number 12. All these elements are called D block elements. The D block elements belong to what? They are called what? Transition elements. The D block group elements are called transition elements. So these all are what now? D block elements. Is that clear, ma? So D block elements from where to, means which group to which group, ma? The D block elements are from scandium, means the starting element of D block is what? Scandium. So scandium to zinc, yttrium to cadmium, lanthanum to mercury, actinium to hafnium, rutherfordium. Actinium, rutherfordium up to copernicium. Lanthanum, hafnium up to mercury. These all elements are D block elements. These elements are what now here? D block elements. See here. Now it is D block elements. These all elements belong to what? D block. D block has which group to which group? Group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So group IUPAC group number 3 to IUPAC group number 12. These 10 groups belong to what? D block. D block elements are called transition elements. And group 1, IUPAC group number 1, IUPAC group number 2 will be called what together? S block elements. Group number 1, group number 2 together called S block elements. Because the last electron enters into differentiating electron enters into what? S orbitals. That point keep in mind. So after this, it is S block. It is what now? S block. These two together S block. Now it is D block. After that, P block will be there. After that, P block. So the P block elements. The P block elements start from which group now? Group 13. After group 12, what will come? Group 13. Group 13. So now here lithium, beryllium completed. Na? Lithium, beryllium. Next what? Boron. So boron belongs to group 13. Group 12 is over. Na? Group 12 is what? The last group of D block elements. After that, group 13 will be P block element. Why it is P block elements? Why this group is P block group? Because the last electron of these elements, the last electron means differentiating electron of these group elements will enter into P block, P orbital. The differentiating electron of these elements enters into P orbitals. Therefore, these groups are called what now here? P block groups. So group 13. Group 13 is called what now here? Roman number 3A. Roman number 3A. Okay. Boron. So after that, what now here? Boron, aluminum, gallium, indium, thallium. All these elements belong to group 13. Boron, aluminum, okay, indium, gallium, thallium. All these here. Next group. Okay. 13. Next group 17 I'm taking here. Group 17. So group 17 means what? Roman number 7A. Roman number 7A. So Roman number 7A elements are what now? Fluorine, chlorine, bromine, iodine, acetine. All these elements called group 17 elements, halogens. Group 13. Okay. So group 13 what? Boron, aluminum, gallium, indium, thallium. Boron, aluminum, gallium, indium, thallium. Okay. So next one what now? Group 17 what? Group 17 fluorine, chlorine, bromine, iodine, acetine. Okay. This one remember. And group 18 is the next. Group 18. So group 18 is nothing but noble gas elements. So they are called Roman number 8A. Whole notation is what? Roman number 8A. Roman number 7A means group 17. Group 18 is Roman number 8A. Here, what are the elements now? In this group 18, what will be there first? Helium will be there. What will be there now? Helium. I'm writing helium here first. Helium. So this is what group 18. So group 18 is called Roman number 8A. Roman number 8A. So now here, helium, neon, argon, krypton, xenon, radon. Okay, ma'am. Now see here. Now here, what are left over? Some elements are there. Recently discovered elements. After thallium, one more element was discovered recently. After acetylene, one more element was discovered, like this here. So group what here? 13 to group 18. Group 13 to group 18. After copernicium. Copernicium atomic number is what? 112. Atomic number Z equals to what? 112. Atomic number 112 is what? 112 is copernicium. Here 113 discovered, 114 discovered, 115 discovered, 116, 117, 118 elements are discovered here. Okay. So after this 113, next 13th element. After 112, 113th element, 113 element is what? Nihonium. Nihonium. NH means what? Nihonium. NiHO. NiUM. NiHO. NiUM. Nihonium. Nihonium atomic number what? 113. Nihonium. So after nihonium, flerovium. FL. FL indicates what? Flerovium 114. Flerovium 114. And moscovium, MC. Moscovium 115. Atomic number of moscovium 115. And livermorium, LV. Livermorium. So I'm taking these all elements separate here. I'm writing here. So remember first that. First, after 113, after 112, what is that? Nihonium. Nihonium belongs to what now? Group 13. So nihonium atomic number is what now? Atomic number of this one, Z equals to 113. Remember. So after nihonium, I'm writing separately here. So 113, 114, 115, 116, 117, 118. So these are all elements. What first one is what? 113. So atomic number 113. Atomic number 113 is for nihonium. NH. Okay, atomic number 114 is flerovium, FL. Flerovium, FL. Okay, and 115 moscovium, MC. Moscovium. Okay, and livermorium 116. Livermorium, LV. Okay, ma'am. And tennicine. So tennicine TS. 117 atomic number for tennicine. And 118 organism. 118 organism. So now in net also you can search all these elements, spellings and all you can check there. Atomic number 113. If you type, you will get it. Name of the element and symbol of the element and everything about it. So 113th element is what now? Nihonium. 114 atomic number flerovium, and 115 moscovium, 116 livermorium, 117 tennicine, and 118 organism. So 118th element belongs to 18th group, noble gases. 117th element belongs to 17th group. 116th element belongs to 16th group. 115th element belongs to 15th group. 114 belongs to 14th group. 113 belongs to 13th group. 112 belongs to 12th group. 111 belongs to 11th group. Like this, you remember. Okay, ma? So these are recently discovered elements. These all are recently discovered elements. Okay, so nihonium, flerovium, moscovium, livermorium, tennessine, organism. If you write 2 to 3 times repeatedly in the same order 113 to 118, you will get it. Okay, so these are what now here S block, P block, and D block elements. So P block elements start from 13th group and end with the 18th group. So 13, 14, 15, 16, 17, 18. Okay, all these are what now here 6 groups are what P block groups. Okay, why only 6 groups are there in P block? Because in P subshell there are 3 orbitals: Px orbital, Py orbital, Pz orbital. So in the 3 orbitals of P subshell, maximum electrons, how many can be accommodated? 6 electrons. So the P subshell can accommodate maximum 6 electrons. Therefore, how many groups in P block? 6 groups. And why there are 10 groups only in D block? Because in D subshell, the dxy, dyz, dzx, dx square y square, and dz square, 5 orbitals are present in D subshell. So the D subshell with 5 orbitals can maximum accommodate 10 electrons. Therefore, D subshell has what? D subshell has, D block has how many groups? Totally 10 groups. And why there are only 2 groups in? Why there are only 2 groups in S block? In S block, only 2 groups. Why? Because in S subshell, only 1 orbital is there. In S subshell, only 1 orbital is there. 1 orbital of S subshell can maximum accommodate 2 electrons only. Therefore, S block has only 2 groups. D block has 10 groups. Group 3 to group 12. IUPAC group number 3 to IUPAC group number 12. And P block has 6 groups totally. Group 13 to group 18. So this point keep in mind. Okay, so it's about what now here the important elements of S block, P block, and D block elements. So the what here this block is what now here P block, and this one is what S block. Between S block and P block, what will be there? D block will be there. S block elements are what? More metallic elements, and the P block elements contain metals, non-metals, and metalloids. Metalloids means what? Both metallic and non-metallic elements. They have metallic character and non-metallic character. Okay, so between the more metallic S block and what here less metallic, what here the non-metallic P block, between non-metallic P block and metallic S block, these elements are present here. As we go from S block to P block, the metallic nature will be decreasing and non-metallic nature will be increasing. Non-metallic nature increases, but metallic nature decreases. This change is called transition. What is this called, ma? Transition. Transition means what? Change. So that's why the D block elements are given the name what? Transition elements. What are these called? Transition elements. And also remember here, main point what we have to remember is that here lanthanum is what now here? Lanthanum is D block element. So lanthanum has atomic number of what? 57. So lanthanum atomic number 57, remember. Okay, and actinium atomic number 89. Actinium atomic number what? 89. So 89 for actinium and 57 for lanthanum atomic number, remember. And after lanthanum, immediately what is the hafnium is there? Hafnium atomic number is 72, remember. Hafnium atomic number is what, ma? 72. So after 57, immediately what is there? 72 is there. See, after 57, what is there? 72. So 58 to 71 missing here. The elements from atomic number 58 to 71 are missing. That 14 elements, 58 atomic number to 71 atomic number, 14 elements are taken as what? F block elements. Because in that elements, the differentiating electron enters into what? F orbitals. Therefore, they are called F block elements. They are also called inner transition elements. Inner transition elements. Okay, ma. Next, actinium atomic number is what? 89. And rutherfordium atomic number is 104. What is atomic number of rutherfordium? 104. That's why group 4. That's why it belongs to group 4. 104 atomic number is for rutherfordium. So now between actinium and rutherfordium, which atomic numbers are missing here? Atomic number 90 up to 103. Atomic number 90, TO2, atomic number 103. Again, 14 elements. So these 14 elements are also taken as what? F block elements. because in that elements also the differentiating electron, that is the last electron, enters into what? F orbitals. So like this here, the 58 to 71 atomic numbers and 92 103, these all elements are called what now here? F block elements. They are also called inner transition elements. Inner transition elements. So inner transition elements or F block elements we say here. Is that clear, ma? So what are the elements? Tell me. Cerium, cerium, cerium 58 to cerium 58 up to what now? Lutetium, Lu. Lu means what now? Lutetium. Lutetium 71. Cerium 58 to lutetium 71 or F block elements. They are called 4F series elements. What are these called? 4F series elements. 4F meaning what? The differentiating electron enters into what? F orbitals, 4F orbitals. That's why these elements from 58 to 71 are called 4F series elements. And next one, here atomic number 90. 90 is for thorium. 92 lawrencium. Lawrencium. Okay, LR. LR is what? Lawrencium. Lawrencium atomic number 103. So these are called 5F series elements. What are this called? 5F series elements. Because in these elements, the differentiating electron enters into what? 5F orbital. So 5F series, 4F series. How many series in inner transition elements? In F block elements, there are 2 series. Inner transition series, how many? 2 series. First inner transition series is 4F. Second inner transition series is 5F. Remember. Okay, ma. So let's say 4F series elements and 5F series elements are together called inner transition elements or F block elements. F block elements. Actually here, if you take this one, lanthanum. After lanthanum, what is there? 58 na? This 58 to what here? 4F means what? Hafnium. 58 to 71. Between this lanthanum and hafnium, these all elements will be in the 3D form. 3D arrangement will be there here. We have to imagine in 3D, 3-dimensional manner we have to imagine. That means after lanthanum, 58 will come towards your face. Again 58, 59, 60 up to 71. So the elements after 57 will come to your face towards towards your face, and again will go towards what? Hafnium. In 3D we have to imagine. Are you getting concept what I'm saying? After lanthanum, 58 is cerium, na? Okay, 58 will be coming towards your face, and again up to hafnium these elements will go. That means what now? In 3-dimensional manner we have to imagine the arrangement of elements from 58 to 71 between lanthanum and hafnium. So these elements are called inner transition elements. But in 3 dimensions we cannot show in the main table now. In the main periodic table, in the main body of periodic table, we cannot show 3-dimensional arrangement of the elements. That's why we have placed these elements 58 to 71 and 90 to 103. All elements are 28 elements are placed at the bottom of periodic table in the form of F block elements, which are called inner transition elements. Is that clear, ma? So this is what about what now? Long form of periodic table. That is modern periodic table. Okay. So modern periodic table we have to understand like this. So the important areas I told you. And see how many periods in this totally? How many periods? 7 periods. 7 periods. And how many groups? 18 IUPAC groups. Which groups they are called? 18 IUPAC groups. Okay. Now here in 7 periods, which is incomplete period? If they ask you, you have to answer 7th period. The 7th period is what? Incomplete period. It is the first period, second period, third period, fourth period, fifth period, sixth period, and 7th period. The horizontal row is called what? Period. The vertical column is called group. How many groups totally? 18. 18 IUPAC groups will be there. 18 IUPAC groups are present, and 7 periods are the horizontal rows. Okay, so like this now totally 18 IUPAC groups and 7 periods there. Which is incomplete period means what you have to answer 7th period. But actually, according to modern concept after discovery of these elements from nihonium to organocene, after discovery of all these elements, now 7th period also is what? A complete period. 7th period is also completely filled now. In the beginning, when your textbook was printed, okay, when your textbook was printed, the elements, all elements of 7th period were not discovered. That is why that 7th period was given as what? Incomplete period. And also the 6D series is that the 6D series of D block is also called incomplete transition series. 6D is also called generally incomplete transition series. But now it is also complete. 6D series also is complete series because 112 also is discovered. In the beginning, all elements were not discovered in the 6D. That's why it was called incomplete transition series. But now it is what? Complete. But in what SSC, still if they ask you, in board examination, if they ask you which is the incomplete transition series, answer is what now? 6D. Which is the incomplete period means 7th period you have said. That means what now? The 6D series belongs to which period? 7th period. The 6D belongs to 7th period. 5D belongs to 6th period. 4D belongs to 5th period. 3D belongs to 4th period. And 4F series, the 4F series belongs to 6th period. 5F series belongs to 7th period. 5F series belongs to 7th period. 4F belongs to 6th period, remember. So these are all things, if you study with concentration, everything you can understand. Okay, ma'am. Bye. Take care. Good day.